All right. Problem 7 on the midterm. This is just the basic. They want you to do a proof, right? So we're drawing our line. Okay. This is obviously given, right? And then we just got to do what we need to do. PIMDAS, right?
Would the thing just be called distribution?
Yeah, exactly. So we're going to distribute this, right? So we got 20x plus 12, right? And that's distribution, just like you said. Okay? And then everything else just comes down. And then we change our color. Because if we change your colors, I promise you, I didn't do this until college, when I was teaching college. Okay? And one of your aunties or grandmas was like, I need to see the levels. Can you change color every time you change a level? I went, okay, it's kind of weird, but okay. Now I'm like, students loved it, right? So use it, believe me. And then you can see every single stage that you do. Okay? So change your color. What do we do next? So we did multiplication, division from left to right. What comes after that? Addition, subtraction, right? Okay? So remember, PIMDAS is always some type of simplification. Division and multiplication from left to right, that's PIMDAS, right? Right? PIMDAS, sorry. PIMDAS. In multiplication, division from left to right. Okay? Now that's a simplification, but we call it distribution, right? Because we distribute. Okay? And then the next one is addition, subtraction, DAS part, right? From left to right. So we need to find some things, so like terms. This is our whole like terms things, right? So things that are like, we put them together. Now the x is always, the variables always go first. And it's the whole variable. So that negative 4x has got to go out front. And then we have 6 minus 2, which is 4, right? Plus 4, right? And then can we add anything over here? So it's 20x plus 12. And what do we call that? Again, simplification, right? Change your color. Next. This is in algebra, I teach this as transition. Right? We got to get one x. We only need one x. And then we start sat met. Once we have one variable, we can start sat met. We can start solving. Right? But we need to get to one variable. So I teach my students to always move the lowest variable. Now some teachers teach move to the left. Right? I don't teach that. I don't believe in that. Okay? Because then you have to remember that weird rule about flipping the sign when you divide or multiply by a negative number. Okay? With my way, rarely do you ever have to flip the sign. Okay? Because if I add the lowest x, which is negative 4, I always add the opposite. Then I'm going to be adding 4. And what I do to one side, I do to the other. Right? And I'm adding the 4x to both sides, right? And so, this goes away. This will always be positive. As long as there's two x's. When you move the lowest x, the x you end up with is positive every single time. Okay? And then you don't have to worry about flipping the sign. So, this will be 4, and this is equal to 24x plus 12. And so because this is geometry, right? In algebra, we call this transition, or whatever you want to call it, right? In geometry, what do we call this? That's right. Addition, property of equality. Because we're doing it to both sides of the equation. When you do it to one side, it's simplification. When you do it to both sides, It's a property of equality, depending on what you did. In this case, we added. Okay? Here, how do we solve? We start with SAT met, right? So subtraction, addition first. So always the opposite again, right? So the opposite of 12 minus 12, what do we do to one side, the other? It's all algebra, but in geometry I need to know what I did there. And again, we did it to both sides. So what type of property of equality is this? Subtraction. Okay? And so at this point in the game, this should be like second nature, right? Remember when you first walked in here, beginning of the year? Not second nature. Now, this is a proof. Students struggle doing this. You guys, they'll be like, what? How do they struggle doing it? No, seriously. Students in geometry classes struggle. This is the best I've taught this in the 20 years that I've done this. By starting you off from the very beginning with not even teaching you about true proofs, just teaching you to do this. Explain yourself. That's all proof is. And for some reason, it's clicked. Okay? So we've got, what is this? Minus 8 equals 24x. Okay? So now what? Divide. Good. So always opposite. So we're dividing, and we did it to both sides, so I know it's a property of equality, but what kind? Division. Just what did you do? I divided. Okay. Right? Alright, so now we have negative 8 24 is equal to x. Do we stop?
You could.
We could, but we should simplify, right? Right? And how do we simplify? And I've taught you this upside down division thing, right? I don't know if you guys like it or not, but it works really well. What number goes into 8 and 24? 8. Okay. How many times does 8 go into 8? Once. How many times does 8 go into 24? What did we do? Simplified. One side, right?
Yeah.
One side. Okay.
Wouldn't that just come down to x equals 3? Negative 3?
That's it. That's negative 1/3.
Oh, because well, I did what you did. I did the whole problem right, except for the last part. Because,
You just divided this into here
yeah, I put.
and got
24
negative 3.
Yeah, 24 divided by.
Yeah. And so what you did is you flipped it in your head. Instead of 8 divided by 24, you decided 24 divided by 8. And it's very common, right, for a lot of pre-algebra students and algebra students to do. So just remember, if it's a fraction, it stays a fraction, right? Now, the big number always stays where it's at. In this case, the big number's on the bottom. Okay? So the big number's going to stay on the bottom. Okay? So it's really important that if it stays on the bottom, that this number doesn't go away. And it just becomes negative 3, right? Because there's a big difference between having a third of something, right, and having 3 of something. Okay?